Okay, Kristy, you can share your screen as you need. So Kristy is doing a talk on chemistry education research for very busy people and is completely exemplifying an extremely busy person this morning. Kristy has a really unique position in UK higher education, and she teaches between a university and a high school, which is quite an exciting role. So she's teaching students from age 11, the beginning of their chem ed, right through to releasing them out as adults at the end of the process. Kristy also writes regularly and is chair of the editorial board for Education and Chemistry, and she writes for other publications as well. And she's also our resident TV star, having contributed to a number of UK television programmes. So Kristy's active chemistry education research and her interests are in the transition from school to higher education, study habits and balancing equations. So I'll pass you over to, and I'm sorry, I always know people by their Twitter handles. I'll pass you over to Kristy now.
Yeah, you're very welcome to send me kind of any queries and things over Twitter as well. I am going to be a little bit dipping in and out today, which does perhaps exemplify what I'm going to talk to you. Considerably less academic talk in this respect, that this is really a reflective journey I'm hoping to take you on with this morning's talk. So as Catherine says, I am generally a busy person. This morning I've simultaneously been in Egypt and a kettlebells class. So I managed to get back to do this. So a little bit about me and my chemistry education. Many of you will have come across me in various guises. My background is as a synthetic organic chemist. I do my PhD in Glasgow with David Proctor, and he inconveniently moved us all to Manchester in the middle of my PhD, but that has turned out to be for the better. My PhD was sponsored by Pfizer. I did work for Pfizer for a little while, found it rather tedious, and decided to qualify as a secondary teacher, which I did in 2006. So I've been a qualified teacher for nearly 15 years now in high schools. After a year out, sponsored by the Royal Society of Chemistry, working full time at the University of Manchester, I went back into school, and after a few years found myself a little bit restless and proposed this hybrid teaching role. And quite often when I speak to people about this, they assume that I work in an education department at the university. And I don't. I do teach chemistry both at UOM, and that is from foundation year through to chemistry education projects in fourth year. And I also teach at Bolton School, which is a boys' independent school up here in Bolton. So as Catherine said, I teach them when they arrive in their oversized blazers at age 11, right through to mature students and adults who will go out into the world of employment and further study. My first chemistry education publication was in 2016. I'm going to tell you interleaved within this talk are a few research stories that I hope will kind of exemplify some of the points that I'm trying to put across. I have got loads of different interests, but I am trying to balance is the word, balancing equations. I'm trying to kind of narrow them down for a lot of reasons, which I'll go into. I am particularly interested in the transition between school and higher education. So how do the students make that leap between us? And there is a chapter in the Yellow Book on that. I'm interested in student study skills and habits and how they lead into successful learners. I am still an organic chemist at heart, and I love a curly arrow, and I love finding out why people use curly arrows in the way that they do, and that kind of thinking. I examined master's students on that last night. But my niche really is balancing equations, even though I have not yet published anything on balancing equations. I do a lot of other stuff. A fair amount of freelance work, including curriculum design, writing, media work, and education policy. I'm a case study for the Royal Society in terms of something called a braided career, where you have a few strands to your career, but they do complement each other and to a certain extent strengthen the overall package. So yeah, generally a busy person. I'm also a mum. I'm a single parent. I've got a daughter who is 9. And I do try not to have all the wheels fall off at various points. I would say about, I'm going to talk to you about doing this from a busy person's perspective, that there is a certain amount of privilege within this as well, though, that I am a white woman, I'm neurotypical, I don't have any disabilities. I do thrive on being busy. So I wouldn't want anybody to kind of think, oh, we should be like her, because I am approaching this from a position of privilege as well. And I recognise that. Also, I do think the personality helps as well. Fairly known for having a relatively forceful personality in terms of trying to get things done, and sometimes being successful. So there was a file that was sent through, which is more a pro forma really, and I'm looking at this from a UK perspective. I know that there are people here from all around the world, and particularly people from America, maybe in a different kind of context to us. So for those of us that are doing chemistry education in the UK, we don't tend to have PhD students and things like that. So we are approaching chemistry education as an additional job to what we do, rather than something that is at the heart of what we do. So this is really a reflective journal file for you to kind of go along as we go through the slides, and maybe some prompts that will kind of help you to connect with what your chem ed voice is, and what your motivation is and that kind of thing, because I found that those things have really helped me in terms of keeping up my energy as far as chemistry education is concerned. So in this talk, there's a few different strands to it. Initially, I would like to see what you say your barriers are. I'm quite happy to show you what mine are. A little bit about examining motivation, because motivation has helped me to keep going. Something about collaboration, a little bit about the kind of personnel and who you could use to help you within your own institution, and more on finding your niche and how finding your niche can help you. So there is a Jamboard discussion, isn't there? Or you can contribute in the chat, or you can contribute on Twitter. Whatever you'd like. What your barriers, what you feel your barriers are to you doing chem ed at all, for those of you that have not yet started, or for doing more chemistry education work, or what you would perceive to be better chemistry education work. I've got a number of barriers myself, but I'll just give you a minute to I can't see the chat while I'm presenting, but I'm sure Catherine is on it, and I will have a look when this is finished. I'm sure once you start contributing, you'll find that everybody else's barriers are very similar to yours. I feel like I should have gone on 2 devices. That would have been a lot easier, wouldn't it? I would have seen the other side as well. I'll start with mine as well. While you're just doing that, you can keep that ticking away in the background. So my barriers. First one is time for literally everything, and that it can be from keeping up with the literature, data collection, analysis, particularly writing. I do a lot of writing once my daughter's in bed, and that does inevitably end up with me falling asleep. So occasionally you go to something like, oh, have you seen this paper on whatever? And I'm like, no, I really haven't. So yeah, and I think that will be common to the contributions that you're making, that time is a huge barrier. Being a teaching focused person at university, we tend to have very high contact timetables. My workload allocation has no allocation for doing research. It's teaching, admin, and that's pretty much it actually, in terms of what I do. So there isn't any time within a day for me to do this. So it's always going to feel like it is on top of everything else. You also have a split attention effect. I've got 2 different settings, a secondary school and university. So even if I'm in one setting, I've usually got both emails open. I am always thinking about where I am tomorrow. So yesterday I was thinking about the fact that I was in school with students, and I was thinking about the fact that I got this today. So very split attention for me with that. A certain amount of lack of confidence with statistics. That's getting better actually, and I'll talk to you a little bit about that later. I'm not a statistician. I didn't even do A-level maths. All of my experience of statistics is to do with biology when I did biology work. So it's pretty much was limited to things like t-tests, means and that kind of thing. So that I find that with a lot of people that I talk to, that they think because they don't understand statistics or don't feel that they understand statistics, that is a huge barrier to them in contributing to the chemistry education community. I have a research personnel turnover, so I'm lucky that I do have project students who will help me out with gathering data and things, but they change every year, and when they come in, they're novices. So I kind of restart every year. I'm not necessarily building on expertise there. The only person that stays there the whole time is me. And a little bit of ethics as well. So at UOM, we didn't have an ethics framework to work in. And with what we do, you're very cautious because you're using human subjects a lot of the time. And I approached our education department, who ignored me. So the consideration of ethics was for a long time a big barrier, because I didn't want to do anything that was dodgy, and I didn't really know my way through this. It's better that I feel that as a barrier and I'm more cautious than I necessarily go all guns blazing and upset somebody. But I put those barriers out there for you. So we could classify our barriers, and lots of people like to sit down and do this, and we'll classify our actual barriers. Like some of them are actual literal barriers, and I find this with colleagues who are working in relative isolation in quite small teams or just a single person. So if you're the only teaching focused person in your institution, that's really, really, really hard, because you've got nobody to talk to, nobody to bounce ideas off. You're probably carrying a significantly bigger teaching load than those of us that are working within teams. And there are organisational barriers, knowledge barriers and systemic barriers. I would just say it's almost not worth it. What you need to think about is, can you do anything about them? It's cathartic to talk about them, very cathartic actually, but just think about what you could do about them. And we'll, at the end of the talk, I'll come back to what these barriers are and how I've dealt with those. So I want you really to think about what your motivation is to do chemistry education research, or if you, so why do you do what you do? Or if you don't do it, why do you want to do it? So you can put it in the chat or on Jamboard. You could just keep it a note in your notebook, whatever you're kind of keeping alongside with this. Motivation is a really interesting thing, basically. And I found that if I can reconnect with my core values, that makes me a better person in general. And this has happened in a few ways throughout my career. When I started out in teaching, I was on a fast track to management, and actually within 5 years was in an acting assistant head post and had kind of climbed the ladder of teaching quite quickly, but found that deeply unsatisfying. So quite often it's been things in my personal life that have prompted me to reconnect with what my core values are, and every time I've done that, it's led me to somewhere where I'm kind of a little bit happier. So keeping your core values there can really help you to be more motivated towards your chemistry education research. So I'm going to these are a few things that I've heard from various people. They're not attributed to anybody. They're just from conversations that I've had with people, and they can range from great things like, I really like it, or I'm just expected to do it. I've got some project students, I need to give them something to do. A lot about esteem around research focused colleagues, a lot about identity as well. And as the profile of people who are teaching focused has been raised in the UK, consideration about how we move through to getting promotions as well. Like I said, I can't see the chat or the Jamboard, but okay, I'm going to tell you a bit of a story about how I got started. So this is my first chemistry education publication, which is in the Journal of Chemical Education, which is an ACS journal. And this was something that was very much embedded in my teaching practice. So if there are people in the audience who are high school teachers or even introductory college teachers in the US, covalent bonding is one of those concepts that is so key to what we do with so many of our students. And I'd read a little bit of literature, but not loads. I was implementing this activity. This activity was evolving. It was being taken up by other people. There was a lot of interest in it. I was finding not necessarily a measurable change in student success, as far as in any measurable way, like they weren't doing better on the exam necessarily, but the quality of conversation that was happening around their understanding of covalent bonding seemed to be better in the classroom. I didn't have the means to be able to collect that. I didn't have the expertise to be able to collect that. Interesting, perhaps it's something I would go back and do. So I had an idea, I was doing it. This was probably the wrong way to do chemistry education. And I know that there are people in the audience that were alongside me when I did this. So essentially started off with something I was doing and retrofitted it to the literature. I knew that it had a basis in literature. I had read some things, so it was quite long and it was quite winding. I had got a background in writing organic synthesis papers, not education papers. And to be honest, if you're in a large synthetic group, you actually don't do very much of that. You spend a lot of time running columns while your supervisor writes up a load of papers that just get sent off on your behalf. We didn't do a great deal of this during my PhD. So initially it was, where did I choose to publish it? And JChemEd seemed like the best place because of the range of different publication types it had. I submitted the paper in November and it was finally published in April, so that there was quite a lot that kind of happened in between there. I got reviewers' comments back quite quickly. What I found from that is that my PhD supervisor had completely shielded me from the reality of peer review. So I had papers rejected when I was doing my PhD, but I'm not even sure I ever read the reviewers' comments because it wasn't me that was responding to them. It was generally my PhD supervisor. So I had 3 reviewers, and one of it's so stereotypical. One of them was like, yeah, it's amazing, publish it as it is. The other one was like, yeah, you could do with tweaking it a bit. And then there was a final one who you'd think I had murdered his mother. It was the worst possible thing he had ever read. I'm assuming it's a he, it may not have been, they had ever read. Though it had absolutely no place in the literature. Why had I not referenced these really obscure papers that even I, as a researcher at a large UK institution, did not have access to? They're in like the Journal of Oil and Gas or something. So it was brutal. And as someone who was starting out, actually, I took those comments really personally. And now, a few years on, I can say you don't need to do that. They're not personal. Reviewers' comments are reviewers' comments, especially in a large area like chemistry education where there are lots of people working. It's not a personal attack. You just need to separate yourself from it. But it's very hard when you first start out to do that. But what I'll say in terms of motivation is this publication was very much embedded in what I was doing. It wasn't something that felt like extra. This was something I was teaching every year. I was using this activity every year. I was sharing it with lots of teachers at teach meets and that kind of thing. So it was really well connected with what my main job was. And if you're thinking in a kind of Venn diagram where if you can connect your chemistry education research with your day job, then that's really, really helpful for keeping the motivation going. What's going on now? Aha. Right, I'm going to talk a little bit about collaboration because that's another thing that has helped me keep going. I am very lucky actually at Manchester that we're a reasonable sized team in terms of teaching focused people, but we're not a reasonable sized team when it comes to chemistry education. We have teaching focused people who are not interested in chemistry education, who don't really want to do chemistry education projects. We've got some people who are teaching focused because they've been moved from a research track onto a teaching track. So they're not coming to this from a chemistry education background, although they may be curious and they might want to do more, but perhaps not got expertise. We have got people who don't do any chemistry education at all, but will just teach, and any project students that they would have, they prefer to have them in what they consider their specialism to be. So I might say that I wanted mine to be in the lab doing organic chemistry for their projects rather than chemistry education. So I am part of a wide team, and over time we've managed to develop our team from being one where chemistry education was very much a kind of sideline to it being a much more core activity, and we're able to bounce more ideas off each other. But that has been progress over the last 6 years. It's not something that happens quickly. It does evolve, especially when you've got people who are coming at this from a completely different angle. So why collaboration is useful in terms of success in any kind of research, and this is actually from a Nature blog, that really it's in terms of you can maximise your outputs by collaborating with other people, because you've just got more people to do things. You do worry, though, that you're putting a burden on other people by asking them to collaborate with you. You can also maximise your impact, because those people will bring different perspectives. They will have read the literature with a different focus to you. You may be able to attract funding. That's not a thing for us really in the UK, though. But you might be able to get some, maybe from professional associations and that kind of thing. But yeah, like I say, it's not necessarily a UK thing. But what I will say about any funding that does exist is that increasingly it's going to teams and not to individuals. So this is not about having a lone researcher on a pedestal. There is very much an encouragement of team and collaborative activity when it comes to people like the Royal Society or the RSC and the IOP and that kind of thing. It will help you to expand your network. And those people, again, will give you different ideas. There are people here on this call that I didn't know 6 years ago when I started out, and they have come through collaborations and through networking, and my life is much richer for that. Many of them are good friends now that were not in my life kind of 6 years ago when I started doing this. And it really does help you to embrace the new. I find this especially with project students, is they don't look at things in the same way that we do. It can be very tempting to just follow the same old line that you always have done. But when you get working with someone who's different in a different institution, looking at things from a different perspective, then it does allow you to see things in a new light, and to give a different focus on your research. So I have a little diagram that I'll show you mine in a minute. So if you're doing this alongside, you put yourself in the middle, and then you think about your first circle people. These are the easiest people to work with. So these are your day-to-day colleagues, really. So people you would pass on a corridor, not during COVID times, obviously, or you would be in meetings with, and you would knock around who you generally kind of have a conversation with, where it's quite easy. My kind of second circle people are people that I'm in fairly regular contact with. So some of them might not even be people I've ever met. They may be people that I know through Twitter or just know electronically. But these are the people where there isn't so much of a barrier about contacting them. So I could pick up the phone to them or email them quite easily and not feel any real anxiety to it. And then third circle people are really people beyond your immediate networks. So you know that they're there. Maybe you admire their work. Or they're a wider group of people, but you would think very carefully before you stuck an email out there, and you'd maybe have a little bit of anxiety about that. I'm going to tell you a little bit of a story about collaboration, and these are first circle people that I was working with. So obviously we've all been through COVID. We are still going through COVID. I'm definitely still going through COVID, because everybody knows where Bolton is now, because we're always in the news, because we're really bad with COVID. So going through COVID, and at the end of last summer, there was a call from JChemEd for papers that were focused on COVID. I mean, we all knew that all the education literature was going to be full of stuff about COVID anyway. But there was a special edition, and I had been thinking at that point about my year 13s, and we'd been very lucky in the school that I teach in. All of our lads have iPads. We were teaching pretty normally. Right up until the summer, but the government took away the exam focus for us quite early on. They basically said year 13 are not going to have exams, so their assessment is going to be determined by their teachers in another way. But there wasn't going to be that final focus of the exam. So I was teaching year 13s, but I was worried about their engagement in that, because we'd taken away that ultimate goal. We all know that one of the purposes of an exam is to motivate people to learn things. And I was worried about what that would look like for students who were going to join universities that September, having not had a normal year. So you can see that little diagram at the top of that paper. Shows that in a normal year, you'd have the kind of calendar year, and they would have some teaching, and then they'd really, really revise really, really hard, and then they'd do an exam. But in 2020, they may not have had teaching. It would depend. Many schools, because they knew they didn't have exams coming up, abandoned their year 11s and year 13s, our school leavers, because they had so much else going on. There was no real incentive to revise the work that they were doing prior to coming to university. Even my students, who were like forced into continuous Zooms up until June, I had students who I knew were sat outside getting a tan while they were accessing their lessons, particularly galling when they're sat next to their beautiful pond with a nice lolly, and I'm not. So I was a bit worried about this, and I wanted to find out, what did other teachers think, because I knew that I was thinking this, but I also knew I had a really tight deadline. If I wanted to pull this round, I wasn't going to be able to do it on my own. I knew that I could survey people, but I needed some help. And the people that I asked to help me were Mike Hughes and Kat Presland. So Mike is our teaching labs manager at Manchester. So he has a background as a technician, but is very interested. He's always been a fantastic supporter of all of our education work. And Kat Presland works for the RSC, and she's an education coordinator. So essentially what we did, I designed the survey that went out, and then we worked like Billy-O, like really sending results to each other, and we all took a strand and we started working up these results together. And I think I got this paper written in 3 weeks. I wish I could do that again, because my publication record would be much higher. But by working with these two people who I knew, I mean, Mike, he wasn't in the lab. Kat had been made to work from home, obviously. I knew they got a little bit of time on their hands, and they'd always been quite keen. But that meant that I was able to turn this paper around. It's actually been really well received and read by the chemistry education community. And yeah, you can look that one up. But for me, if I hadn't have had Mike and Kat with me, I wouldn't have got this turned round, and therefore that information wouldn't have been there for academics who were returning in September with a group of students. As a little bit of an aside, the results of that really were that they felt that in fundamentals students wouldn't really be lacking. They would be missing things that they would normally learn in a panic. And they worried particularly about practical work and some aspects of the higher stuff that we would do in physical chemistry. So things like Gibbs free energy and entropy, because they didn't think they'd had enough consolidation of that, but they felt fundamentally they'd kind of be okay. That's my little circle. So in the middle, there's me, there's some people from school, there's the people that I work with. Second circle usually are people in other institutions, but some of them are also people within my institution who are research focused people who have big chemical research or comp researchers, but have started to do a little bit of chemistry education work as well. Anybody in blue is somebody that I'm already working with or have published with. I do want to talk a little bit about publishing, because I think we've got a publish or perish kind of idea, and it does still persist. There are loads of avenues for doing this. These are your kind of general science education, chemistry education publications that are the kind of peer review idea. All I would say is the best thing to do is to try and aim for something that you already read. And something that's helped me to be successful is to look more carefully at manuscript categories. It's really easy to be really ambitious and try and write a really big article, but I think you've got to realise that that's not always possible for ours. So if you look at my publications, they are not necessarily a big article. So there are communications and commentaries. There's a book chapter in there, and there are activities. So do read the different types of manuscript for the journal that you are aiming at, because it will help you to focus what you're doing, and you may be more successful because you might be better off to write a shorter paper rather than leaving it longer and collecting more results. Another research story, I'm going to talk to you about changing manuscript type. This is actually unlocked at the moment on JChemEd. My project student, this is the first project student I had who I managed to publish their work from. I was transitioned to ebook provision, and we looked at what the preferences were for our undergraduates, whether they preferred ebooks or physical books. I put an original title in that was "Have ebooks changed the way that chemistry students read?" And it came back for major review, and I was like, I'm a bit disappointed with that. But it turned out that the reason that it was classified as a major review is I had put that in as a communication. Now in JChemEd, a communication is 3,000 words. And somehow they said that the reviewers were concerned that it was quite a brief manuscript, which was weird because it was 3,000 words, which is exactly what they said a communication was. However, they suggested I change it to a commentary. And that there was very little to do actually, other than change it into a commentary paper, and then it was accepted really quickly. So that's a little bit of an exemplification of keeping an eye on manuscript types more than anything else. So yeah, you can see that a commentary is 2,000 words, communication is 3,000 words. I actually think it was 3,300 words, and somehow it was a commentary. I'm not saying that reviewers always make sense. A little bit on personnel and student projects. Who do you have to help you with your data collection and analysis? Do you have project students? Are they BSc or MChem, third year, fourth year, summer project? What's their background? I am lucky that I've got third year group project people. So I usually have 1 or 2 of these a year, and there are 4 students in those groups. So usually I have to write a 4-stranded project for them. I also have between 1 and 3, depending on the year, 4th year MChem project students. These are novice researchers though, and that can be a limitation of what we do. Within the framework at Manchester, we don't train them up in chemistry education at any point. All of their training in practical chemistry and things, or anything they consider to be a project, is practical focus for if they were going to do a research project in a lab. So when they arrive, they don't necessarily know very much about chemistry education. So their projects are often quite broad in scope, and you tend to find at the start what they do is like throw like their spidey fingers out and they want to do this and this and this and this and this, and they want to do everything. So quite often they're quite broad at the start. But looking back at that ebook paper that we wrote, that was my MChem project student in 2018. And originally her title, her research question, was to look at the reading habits of undergraduate chemists and whether they matched what we thought they did. So she collected loads and loads and loads of data. There was actually a slight error in it. And I knew I wanted to write it up, but I knew I couldn't write it up with that original title on it that was her actual project. So what it ended up being was a much smaller strand that came out of that project. So if you're using undergraduate projects, that's something to keep in mind. It can be very difficult to get a publication on the whole project. Try to think about smaller areas within it. So I've been successful in doing that just because I've been able to take a strand out and to strengthen that a bit as well. So it's just about really accepting the limitations of what you're working with. Holly was a fantastic project student, but she was a beginner. So I wasn't going to be able to publish everything that she produced. I'm going to skip over that a minute. I'm going to talk to you a little bit about finding your niche, because this is where I think there is a real benefit to anyone as a chemistry education researcher. And you see this with the people within the US that have got a much stronger chemistry education focus, is they tend to have a thing that they do. And I think sometimes for those of us in the UK, we can be a bit like, oh, I'll do a bit of this and a bit of that. So I am now moving into doing much more on balancing equations. And the reason is that it connects so well with what I do as a teacher. I have taught this topic every year of my teaching life. I know that it causes loads of frustration. There is so much discussion about it on social media. You can see down the left there the things that people are talking about. They're often talking about methods. The literature is full of methods. So there are people talking about it informally through modelling and grouping, and there's always people who are like, I have got the best way to do this. And then there's some in the formal peer-reviewed literature, algebraic, matrix, computational, really, really interesting methods. But this idea of methods, but doesn't really find anything out about what students think and that kind of thing. So there's a little bit of a gap there. These are 6 research questions that I've been working on. So it originally started with that question number 1, and it was very much embedded in my school practice. We wanted to do a little research project in school, and this actually moves into the learning loss idea as well. We just wanted to know, do boys lose this skill over the summer? That summer we had an 8-week summer break, and let's face it, there's not going to be very many of them that were practicing balancing equations that summer, playing on their Xbox and getting a tan. So we did a short project to see if they lost the skill there. And there are various other ones that have followed on from that, but I'll tell you how they connect in a minute. So it started with this research question. So I had to develop a test instrument. I had to limit my study, otherwise it would have got rather too large. So I went for the lads in the year that they've been taught it, which for us is year 8, which is 12 and 13-year-olds. I gave them the test instrument before and after the summer break, and I did a paired t-test because I was starting to gain some confidence with statistics. In terms of designing the test instrument, I looked in the literature and there wasn't really one. There were some, but they didn't suit the age group that I was working on. So I did this mainly through discussion with other teachers. I went for a mixed test instrument, so it's not ramped. Ramping is where it starts off easy and gets harder, but we didn't want to do that because we didn't want people to give up in the middle. We had to take account of accessibility factors. So they were things like the font that we used. We all know the problem with whether it looks like an I or an L when it's chlorine and that kind of thing. Plenty of white space around the outside is one of the things that we know is good for accessibility. And we had a little confidence rating thing, which actually didn't work out very well in the research. The results from the study are that we looked from year 8 going into year 9. And really, there wasn't any difference. So we did t-tests, we looked at effect sizes. Really, there wasn't much difference. So they didn't really lose the skill, which is quite nice, but also not really publishable. So all of these are now starting to link up. So from starting off on that, I started to bring up some other questions. So I then had a test instrument. So I started to look into what makes an equation difficult to balance. So this research question 2, I've got 500 responses from schools in England and Scotland, actually. And this has led us to this research question number 5 as well. This is nearly to the point of publication. There's just a little bit more stats to be doing on it. But what we found is that the Scottish school students were better than the English students, but they were also older when they were first taught how to balance an equation. So our intention over the last year was to explore why these Scottish students were more successful. What were they doing? There is some bits in the literature about if an equation is more meaningful to students, then they may be more successful when you first teach them to balance it, rather than seeing it as an algorithmic approach. So you can kind of see how that one links. Question 2 led to kind of 2A. I've looked at some external exams so GCSE, Scottish Highers, Irish Leaving Cert, to see if they're asked to balance an equation in that and what's the level of difficulty there. The first one led to me looking at some school data to see, do they get better over their time in school? Which they do, except I've got a chunk of stuck boys who I would consider to be of middle achievement, who don't make as much progress as the others. The higher boys get to getting 12 out of 12 much quicker. And then as a result of COVID, research student Yoon, who I think is on this call, started on question 5, but when we went into lockdown again, and with the additional pressures on schools, we didn't really want to put any more pressure on schools to be doing our research instrument for question 5. So then we moved on to question 6. So we looked at what factors teachers were using in choosing where they were putting things in the curriculum. For me, in terms of benefits of finding a niche, it does increase your confidence as a researcher. Like now I know my literature really well, and I'm much more able to guide the people that work with me. So it really can improve your handover between project students. Let's face it, our lab-based colleagues do this all the time. I always think it's so much easier for the project students who might be a big synthetic group, because they get a copy of the previous project students' work. They've got so much less to do, so much less to learn. So if you find a niche in a line of research, then that can really help that. It reduces your literature review burden because you're only really looking in one area. As interesting as other things might be, that's just one thing that you're going for. You can start to build a bit of a reputation. A lot of people now know that this is something that I work on. And also, I think it makes you make better use of your research participants because you're really just focusing on one area. We are at the mercy of people who will volunteer to do surveys and to do survey instruments. And for me, that's working with people in schools. So I don't want to ask too much of them. And that's where I think it is. So we're just at the end of this, going to return to my barrier. So I said that time was a huge barrier. So on the right hand side, I put kind of how I overcame that or how I'm trying to overcome it. For me, it's about being realistic. I have to keep my research questions pretty tight. I'd love to do some kind of big academic study, but it's not realistic for me. And I do use project students for it. In terms of split attention, I do use this to my advantage. So where I work, I research, and that's very helpful in making the maximum use of my time. Lack of confidence with statistics. Some of this is through collaboration. Fraser Scott has been very kind and helped me with a lot of things. I still have a copy of Statistics for Dummies on my bookcase up there, and I do still look over that. Some of it is learning by experience as well. My research personnel turnover, really, it isn't the turnover that's the issue. It's the fact that they're novices when they come in. It's great to get a new project student every year, but what we're looking at now is how we can amend our organisational structures so that they are better prepared when they come in. So in terms of front loading the project time with some training at the start rather than doing it as they go along. And the ethics, like I said, the education department wouldn't talk to me. So I've spoken to another people. Catherine, I remember talking to you about what do you do about ethics in yours. So asked a number of people about what happens in their departments in terms of ethics structures. So now we have implemented a department procedure which is based on peer review of each other's projects, and that has been really helpful. And I also talked to other researchers about it as well. A few acknowledgements. I've got a number of project students who have produced so much work, but really as well, on top of them, colleagues, collaborators and supporters. I don't think I would be able to do anything if it hadn't been for people who encouraged me, especially at the start when I had a huge amount of imposter syndrome coming to this kind of work from being just a teacher. And I'm sure I've missed plenty of people out there on that. I'm not sure I've got a great deal of time for questions. That is my Twitter, those are my emails, and you can find me in various disguises on Education in Chemistry, Chemistry World and Nature Reviews Chemistry. But happy to take any questions if we have any time. I was trying not to talk too fast.
No, don't worry, we've got a couple of minutes for questions. Thank you, Kristy, that was a fantastic talk. So if anybody would like to ask a question, you know how it all works. If I've got an eye on Jamboard chat for hands up. I've got an eye on Twitter as well.
I can't see anything on this screen. I don't know what. I'm not used to using Teams. That's my problem.
We've got a hand up now from Madeline Schultz.
Okay.
Hi, great talk. Thank you. I think you might be my clone. I think our barriers are superimposable. I wanted to just ask, this is obviously a trivial question, but how on earth you got ethics to do within that 3-week time span for that survey, or does your institution have a pathway where they say it doesn't require ethics review?
Yeah, so that one in particular, the lowest risk thing I can do is to talk to professionals about their jobs. So essentially that doesn't have to go through a peer review, because if you're asking a teacher about something in the professional capacity, that is considered to be very low risk, that it doesn't even need anybody to sign it off.
That's hilarious, so it's because my institution would consider that one of the highest because of oh my God, they go off.
Yeah, so yeah, it's in the bands that we have, you know, talking to adults in a professional capacity is one of the lowest risk activities that I can do, especially through an anonymised survey and that kind of thing. If I'd been interviewing them, I probably still could have got away with it with a bit of, it depends who the peers are as well. So within us, it's, like I said, like the education department, it's much more formal. Within the team of 8 of us, it's a case of getting 2 people within the team to review it. So it depends if you know how well you know those 2 people.
Thanks.
It's probably not as professional as it could be, but we're getting there.
There's been a couple of really interesting comments, actually. One from Stacey Bretts about the idea of not publishable and how that's uncharted territory in SIR, that we need to value and create precedents for publishing studies that don't show effect size or have no difference, so that people can build on them. And another lovely one. I need to
just talk about those things anyway. You know, it might be quite reassuring if I put out there to people, yeah, you know, they don't actually forget how to balance the equation over the summer. But unfortunately, I don't know, not sure who would take it.
And another one from Ira Kaspari, who wants to challenge that one model of academia, which is maximize output, production and success. with the danger of undervaluing the humane qualities of the people we research and work with, which it definitely resonates with me, that comment. So
yeah, I would completely agree with that. But it is about finding the balance, isn't it? I certainly, when we began chemistry education projects at Manchester, essentially we had to align them so carefully alongside what were lab-based projects in order to even get them there in the first place. So it feels like we're just making baby steps every time.
I would agree wholeheartedly. Every year my angst at having to align a chem project with assessment criteria written for bench organic agro pushers is very hard. Any other questions? Okay.
I'm around for the rest of the day now. I have